Hello everyone. Hope you're all doing well today. Hope you all had a great weekend. I don't really have a whole lot of announcements to start off today other than just to remind you that exam regrades are due by the end of the day today. If you've already submitted regrades, chances are I probably already got to it. I did a whole bunch of them late last week, so I don't think I've done all of them yet, but I did a whole bunch of them late last week, and I'll probably wrap up whatever is left tomorrow. So if you're still thinking about whether you need to submit a regrade request, today is the day. If you want to chat with me after class or something about it, I'd be happy to talk to you. Otherwise, we're just kind of chugging along. We've got 2 weeks left until spring break. We also have 2 more topics left to cover before we take our next exam. So we're going to see a new topic this week. We're going to see another new topic next week. And then when we get back from spring break, we'll have our second exam. So that's kind of what the schedule is looking like going forward. Today's topic is a very, very, very important one. So I think our section last week on input and output was a nice little kind of breather after exam 1. A little bit of a lighter subject. Hopefully you haven't been struggling with it too much. The Flag Studio is a very popular one. It's one of my favorites too. Really like it. But what we're talking about today is extremely useful, extremely functional, and also can be a little bit mind-bending. We're going to be changing the way that we view programs quite a bit today. Everything that we've done up until this point has taken sort of a similar structure, right? We have this thing called public static void main, and we just start at the very first line, and we go all the way down until we hit the end. And honestly, that's still true. The biggest difference between the way that we've been doing things and the way that we're going to be doing things now is that we may jump around a little bit. So there's some more code up here. You can see on this first example for Module 5 that I'm looking at, if you run this code, it just displays a little song, right, about a 4-leaf clover. And the thing to notice is that there's some repetition in this song. That's not uncommon. It's not an uncommon thing to happen in songs, right? Typically the chorus or some other parts of the song will be repeated. But one thing that we really don't want to do in our code is have to repeat the same chunk of code over and over and over again. That's something that as programmers we really don't like to do. There's a lot of reasons why that's undesirable, but consider that I'm only human. I make mistakes. And if I make a mistake and then I copy paste that mistake 5 times, I now have 5 mistakes, right? Do you have a question right here? You guys have a question? Okay. So instead of copy pasting code over and over and over again, the programming way of doing things is to try and write that code once and then reuse that code over and over and over again. And methods are one of the major ways that we have of doing that. So a method is a way of assigning a name to a behavior. Contrast that with variables. We're assigning a name to a piece of data, right? We're assigning a name to some piece of information that we want to keep track of. Methods are ways that we assign names to an action, a piece of behavior that we want to perform. So if there's some kind of behavior that I want to do over and over and over again, that's a big clue that we're going to create a method. And this is about as simple as it gets for a method where we've extracted the chorus out into the method. And then anywhere that we have the chorus, instead of just copy pasting these 2 lines to have that chorus text come out, instead we're going to replace that with what's known as a method call. So the line that I've got highlighted right now on line 14, this is what's known as a method call. I can tell it's a method call. The giveaway is the parentheses. At the end, every single method call will have parentheses at the end of the line, right? Or at the end of the expression. And so what this code is telling us to do is says, go find the behavior named chorus, go find the method named chorus, and then go do that stuff. Whatever the code is that's in that method, go do that stuff. And then when you're done doing that stuff, I want you to come back here. I want you to return here, and then keep going along this way. Keep going down and doing this stuff. So instead of just starting at the top, working our way down to the bottom, methods are now going to allow us to jump around all over the place, which does seem like it makes things more complicated, and it kind of does in terms of how we visualize the flow of our code. But remember, the reason that we're doing this is to try and consolidate and organize our code such that instead of reusing code over and over again, we can abstract that out into something called a method and then reuse that method over and over again. Let me show you how this actually works using the debugger. I'm going to try and use the debugger a lot today because I think it's very helpful for illustrating the path that we take through the code. And notice that I'm already kind of starting off in a little different spot. We've seen this before, public static void main. Today is actually a great day to explain exactly what this is. This is called the main method. So it is a method, just like all of the other methods that I'm going to be looking at today and showing you today. The big difference between this method and the other methods that we're going to be looking at, the reason why you've seen this one before and you haven't seen a whole lot of other methods yet, is because this method has a special purpose. This is the entry point, this is the beginning of a Java program. So where do I begin? If I'm looking at a file, right, and I want to know where do I start? What's the first thing that I'm going to do? Main. The answer to that question is look for main and start there. So the very first line of code that gets run is actually not necessarily the first thing in the file anymore. It's whatever the first thing in main is. That is the first line of code. So maybe main's at the top of the file, maybe it's all the way at the bottom. It doesn't matter. Wherever main is, that's where we begin. That is the starting point. So line 14 here is actually the first line that's going to get executed, and that's where I've set my breakpoint. I'm going to go ahead and start this in debug mode. And we've paused at line 14, which says to do this chorus method, this stuff up here, right? I'm going to do this a couple of different ways. One using the way that we've been doing up until this point. The step over method, if I click on this button, you'll see that it printed out 2 lines of code. I want you to think carefully about what happened here. It actually went up here, did both of these things, right? And then came back to line 15 once it was done. So the method always comes back, right? Once I call a method, it goes off and it does whatever the method says to do, but then it always comes back once it's done. It always returns once it's done to wherever we left off so that we can continue on. So after we've done that, the next line is line 15, 16, it just prints out more stuff, right? And then we get down to this code at the bottom, we can see I get the same 2 lines over again, but I actually didn't call the method this time. I just print them out directly. This is exactly the kind of situation I'm trying to avoid, right? Because I have a method to handle the chorus for me, I would much rather replace these 2 lines of code with the call to the method. That's what it's doing. You can think of a method as being kind of a rubber stamp of sorts, right? So anytime I use the chorus, it's just going to rubber stamp these 2 lines wherever I tell it to, right? Just boom. And we can verify this by running the code again. Seeing how it runs, right? No change. But let's run this in debug mode again, and I want to show you how to use the debugger a little bit differently today. Since we're introducing methods, there's a new tool that we can use as part of the debugger to help us out, to help us understand the flow of our programs. I've been using this step over button with the debugger, and I'm still going to. That's not going to stop. I've been avoiding the usage of this one that's called step into. It's right next to the step over button. But today's the day. Today's the day that we look at this step into button. And what it actually does, you know, the first time that I clicked step over, it just went down to line 15, right? But if I click step into, look at where we go. Oh, okay, it's taking me to the method that's being called. And now it's letting me walk through that. So I can actually see the flow of the program, right? I'm going to use step over again. Prints out the first line, prints out the second line. Now the method is finished. I've hit the end. There's no more work for me to do, right? So it's going to return. It's going to go back to wherever the method was, right? And then keep going. Okay? And then we'll keep stepping through, step through, step through, step through, until I get to this other method call. I'll click step into again, and notice that I jump right back up to the top. I'm going to reuse this code. I'm going to reuse this code by calling the method, step through. Okay, the method is again over, and I'll return back to where I started from, which is the main method, and try to keep going, right? But now the main method is over, the program is over. Okay? It gets more complicated than this, but does anybody have any questions about this action of jumping to a method and then returning back before we start introducing some more things into this? Yes?
Can you like nest methods together?
Yes. In fact, I will show you an example. That's a great question. The question was, can you nest methods together? So let me be careful about how we define that, right? I can't declare, so we haven't looked at this yet. How do we actually create a method? I can't make a method inside of a method, but I can call methods from other methods. So I can actually say, go over here, go over here, go over here, many different times. Yeah, and it's a great question. In fact, one thing that now is as good a time as any to bring your attention to it, because I'm going to be talking about it quite a bit today. Whoops, what did I do here? Forgot to stop my last execution, I think. Let me try that again. So the other part of the debugger that I want to introduce to you today, and that I'm going to be talking about a lot from here on forward, both today and next week as well. This part over here, this left side, is called the call stack. The method call stack, where stack quite literally is intended to be interpreted as a stack of plates or stack of papers, right? Same kind of idea. As I call a method, that method gets added on. Oops, I hit the wrong button there. I meant to click step into instead of step over. Sorry about that. Let me try that again. As I call a method, you'll see that it gets added to the stack. So the way to interpret the stack from the bottom to the top, right? The bottom of the stack is always going to be main. That's where I start. Just keeping track of all of the methods that I'm traveling to throughout the life of the program. So main's always going to be at the bottom. Main is always where we start. But main's going to call other methods like it's done here, and once it does that, you'll see that it gets added onto the stack. And then once this method is finished, how do we know where to return to? Well, it looks at the stack and says, okay, I need to return to the main method, line 14. That's where I came from, so that's where I'm going to go back to once I am finished. And so once we finish out this method call and step through, you'll see that, okay, the chorus method, this first one is over. It's no longer on the stack, right? Once the method is finished, it pops off the stack. That's actually the computer science term for it. And then we've returned to the main method exactly where we left off. And the next time I see the chorus method get called, if I step into it, you'll see the same thing happen, right? I'm in the chorus method, so that's at the top of the stack. But notice that it's telling me that the place I need to return to is the main method on line 21 this time, right? Which is this one down here. So it's always keeping track of where it came from, so that once the method is over, it can return to that spot and continue on. The method call stack is what's doing all of that for us. All right. Great question. Any other questions before we start inserting some more stuff into this? Okay. So let's take a look at a slightly different song. This is a song about four-leaf clovers. I'm going to switch down to section 2. There's another file called song.java. I actually don't know that four-leaf clover song, but this song I know, and I imagine a lot of you probably know this one as well. My 3-year-old son is big into Old MacDonald and Itsy Bitsy Spider and all the fun kids songs right now. But the nice thing about Old MacDonald, there's a pattern. There's a very clear pattern to the song, right? What gets replaced, the name of the animal and the noise that it makes gets replaced, but the overall structure of the song remains the same. And as programmers, we actually really like to identify those similarities, those things that are constant and the things that are changing. What that allows us to do is have a method with parameters. So in the last example, we didn't have any parameters. There was nothing inside the parentheses, right? We just called the method and it does the stuff inside of those brackets, and then we're done. This one has some parameters. This is a way of tailoring the way a method is going to execute, preferably so that it's useful in multiple situations, right? You could conceive of, me writing a method to do this for cows that go moo, and actually writing out cow and moo in all the spots, but then I would only be able to use that code for cows that go moo. Then if I want to do ducks or dogs or cats or some other animals, right, I would have to make another method for those animals. Whereas using these parameters allows me to have one method and then customize every trip through the method with a different animal and a different noise so that I can reuse the same code in multiple situations. And what that means, since we have these two parameters, animal and string noise, when we call the method down here, we have to supply values for these. So these parameters are really just placeholders. When I'm writing all of this out, I don't know what this noise is, right? It's just a placeholder. It's just like a blank, right? I don't know what the animal is. But when somebody actually calls the method, they're going to say, all right, substitute cow in for the animal and substitute moo in for the noise that the animal makes. And then these values quite literally will be assigned to these parameters. These are very much like variables. And then you substitute it into the code. I would like to show you that in the debugger as well. So again, notice where I started my breakpoint. I didn't start it up here. This is not the first line of the program. The first line of the program is main. So we have to look for main. This is going to be the first line of the program, whatever the first line of main is. I'm going to click the debug. I'm going to do this a few different ways, right? Again, I'm trying to show you, one of the things I'm trying to show you is the difference between step over and step into. When I click step over, it's going to run the entire method without letting me walk through the method, right? It's just going to do it all. So if I click this step over method now, you see I get the whole verse. Old MacDonald had a farm, and there's cow and moo, right? Substituted into the song. Step into allows me to actually visit that method and walk through that method one line at a time to see what that method is doing, right? They both get me to the same place. It's just, do I want to see what the method's doing or not? That's up to me as I'm walking through the program. So if I click step into on this one, okay. Here I am in the verse method. Over here on the right-hand side, we can see my parameters, right? Animal has been set to be duck. Noise has been set to be quack. That's taken directly from here when the method has been called. And so as we go through this method, it's going to use those parameter values. One line at a time, we'll see the song continue with the duck verse. We're finally done with that. We return back to the main method and we're finished. Everybody with me? Any questions about what just happened there? Some other loose ends before we move on to another example. These are non-optional, right? I have to supply it. So if I tell you that this method needs an animal and a noise, those are non-optional. I have to give them to you. So I can't just say, just make one for cows and then not tell you what the noise is. That's not allowed. So if there's two parameters listed up here, then I have to tell you what those two values are down here. You can also use variables for this. So if I have a string, noise equals moo, right? I can certainly do this. This is okay. This is perfectly allowed. The types also have to match as well. So if, you know, I can't plug the number 7 in here because that's not a valid string. This is very clearly stated as a string. And the order matters as well, right? Animal comes first and then the noise. So pay attention to all of those things when you're deciding what to put into your method calls. The order matters, the types matter, the number of parameters. All of that stuff matters and is important to pay attention to. All right, let's talk about actually writing methods. So far you've been just given some methods. We've been examining how they work, but we're going to ask you to write some from scratch. So we're going to say, all right, here's a problem that we need you to solve. Write a method that can do this. Okay, let's talk about how to do that. What the different parts of a method are, and how you might choose to write your methods. I'm going to move on to the next example here, which is going to be the payroll calculator. This is code that I grabbed from the website. Whoops. Here we go. This example code is from the 131 text website. So I grabbed this code and included it here. And the question is, can we, you know, right now we're doing everything in main. Can we write a method to do this stuff for us? The answer is yes, but then the question is, okay, how? How do we write that method? What does that look like? What parameters should the method have? So on. What should the method do? Look for the repetitions. Look for the parts of the code that are repeated. Yes, some of the values might be different, but the component parts are the same. There's an employee, there's a rate, there's a number of hours that have been worked, right? The computation is the same. So anything that's changing, these values are changing. These are probably going to become my parameters. Anything that's staying constant, like this stuff right here, you'll notice these two lines look exactly the same. That's going to go in the method body. So we can start trying to construct this method. When we're writing a method, at least for now, the rules for writing methods are going to kind of evolve for a bit over time. But for now, if I ask you to write a method, the first things that you're going to need to type are public static. And I have been sort of dodging what these words mean. We are going to talk about it at some point in time, but not really today. Today we have other things to focus on. So you can just, for now, treat public static as sort of the magic words that we need for methods to run. I understand that's probably not satisfying to just have, you know, magic confusing words in there, but we will talk about those in future classes, I promise. The next thing that is expected here is what's known as a return type. So I've used that word return before. We haven't actually used the return type yet, and so far all of the methods that we've seen have had a return type of void, which actually means that they don't have a return value. They're not returning anything. That's something that we'll go into more detail on. You'll see that's actually the next section, return. So what does it mean for a method to return something? We'll see that soon. But for now, if the method doesn't return anything, we'll just use void. You'll notice that main actually has void as its return type. Void methods are very common. The next thing that's going to come is the name. What do we want to call this method? Here they're telling us what they want us to call it. Calculate pay. Method names should be verbs. Methods are actions. Methods are behaviors. Methods do something. So your method names should be a verb to represent that fact. So this is a pretty good method name. Calculate pay, that's an action. That's a verb. After the name, we're going to put parentheses. If we don't have any parameters, then we can just leave those parentheses empty. But they do need to be there, always. We can't leave them off. If we do have parameters, then we need to include them here. And so, in this case, I'm trying to make the claim that while these values exist, the values change for every employee. So these make good candidates for parameters. Any values that are changing, right, but exist every time through the method, that's kind of the definition of a parameter. So I think employee hourly rate and hours worked are going to be my parameters. We have to declare them just like we would declare variables, with a type and a name. Notice that I'm using commas to separate all of the parameters. Oops. Got an extra parenthesis in there somehow. I'm not sure how that happened. It's okay. And then once we have, so it's a little bit long for me to fit it on the screen because I've got 3 parameters there. But this part of the code that I've highlighted, this is called the method signature. So this tells us what goes into the method and what comes out of the method, as well as some other information. The method name. The public static does mean something, even though I haven't really told you what it means yet. The stuff that comes in the curly braces, so you'll notice I've put curly braces after the method signature, that's what's known as the method body. So that's the actions that the method's performing. Any code can go in here. Any lines of code that you've written on past assignments, fair game. Any lines of code that you can think of. If statements, loops, the whole deal. All that stuff can go here. This is just the behavior, the actions that the method is performing. So for this case, what do we want? In this case, I've already identified that these 2 lines are sort of the repeated behavior. I'm just going to copy those lines directly up here. It's upset at me because this weekly pay variable doesn't exist. Well, I can make it exist. I just need to tell it what, whoops. Just need to include a type out in front to declare it properly. In the past, it was declared here, but we didn't take this in as a parameter. We're computing the weekly pay. So I think with that little tweak, we're basically done. And then what that allows us to do is remove all of this code and replace it with, what's the term again to use this method? If I want to use a method, we have a name for that. It starts with a C. Call the method. Yeah, call the method. So instead of duplicating this work, we're going to replace that with a method call. Calculate pay, and then plug in the parameters, which I deleted those values. Fred, 12, 50, and 20. Okay. Fred, 12.50 per hour and 20 hours, right? Did I spell it wrong or something? I spelled it wrong up here. That's another thing to pay attention to though, right? Like the computer is going to notice. Does have to match exactly, so be careful. And I'll leave it, this is the quote-unquote new way, and I'll leave it the old way so we can kind of compare and contrast what happens when we run these 2 side by side. We can see that it looks the same in terms of the output that we get. Of course, the values are different, but that's to be expected because that's what we see here, right? I can replace this with a method call as well. So Amir 15 and 35 is going to get replaced, whoops, with another call. Amir 15, what was it, 25? 35, okay, whatever. These are no longer necessary. There we go. I can run this program once again, see that it generates the exact same output that it did before, right? This is actually a really cool thing that I've done. Maybe maybe it doesn't quite seem so cool for you all who are just learning about methods for today, but as a programmer, this is very satisfying to me. I've taken code that was duplicated. I've put all of that duplicated code into one place and replaced it with 2 method calls. And actually, this is even better because I could reuse this method not just twice, but as many times as I need to for as many employees as I have, right? That's very useful. It's a very useful thing. The code, I would argue, is organized better and in some ways easier to understand, right? I'm calculating pay for 2 employees, and I can see exactly what values are being used to perform those calculations. We have a name for this. This is actually a skill that we do all the time and a skill that we're going to ask you to do on the next homework assignment. I rewrote the code, but I did not change the functionality. It did the same thing when I started as it did when I was done. My goal was to rewrite the code but not change the effect of the code at all. The name for that is refactoring. So when I rewrite the code for the purpose of organization, for the purpose of cleaning things up, making it easier to understand, I'm not trying to change how the code works, right? Just trying to reorganize, trying to make it a little easier to read. That's called refactoring. And it's a very important part of programming. I liken it a lot to, cooking something in the kitchen. I'm a big cook. When I first make something, I make a big mess. But then I go back and I clean it up when I'm done. The same thing's true for code. When I'm solving a problem the first time through, I'm probably not worried so much about, am I using enough methods? Am I duplicating code? A lot of times I'm just trying to solve the problem. But once I've got the solution to that problem, then I'm going to say, all right, let me go back and take a look. Is there anything that could be turned into a method here? Anything I can do to clean this up, make it a little easier to understand? Any questions on this one before we move on? Yeah, what's up?
Could you set like a input line within the main method and then set those inputs to be like the parameters for the call method?
By input, you mean like scanner or something like that?
Yeah, like a scanner, and then you set those to be like the parameters for like to calculate pay.
Absolutely, yeah. If I wanted to, you could bring scanner in. Yeah, no doubt. And then ask the user to type in a name, and yeah, absolutely you could. 100%, that would be possible. Good question. Any other questions? Yes?
Is there a limit to the number of parameters you can put like in?
Oh, that's a good question. Yeah, the question is there a limit to the number of parameters? I don't think that there is. So I can put commas, here and keep adding parameters. However, that doesn't mean it's a good idea, right? I think most people would probably agree that after a certain point it becomes a little bit difficult to understand. In fact, the number of parameters that I would accept is probably smaller than you might think. If I'm writing code, professional grade code, right? Not just like hacking around. I want 3 parameters or less on every method. So this is already pushing limits. I look at this method, I see 3 parameters, I'm like, can I make that less? Can I make that 2? Sometimes maybe I can't. But certainly if I see 4 or 5, I'm going to really push to bring it down to 3 at the most. Yeah, good questions. All right, let's talk about a concept that I feel like y'all have kind of seen before, but maybe never really thought about in a formal way. It's a concept called scope. So this scope is a term that we use in conjunction with any variables that are in the code. And you'll notice that we've introduced this concept of a parameter today. Parameters really are just variables though, right? Variables that exist within the method. The way to consider scope, however, is if I declare a variable within a scope, that variable only exists, is only able to be used within that same scope in which it has been declared, which sounds like a very complicated definition, but it's actually a pretty simple one to understand in practice. Here, I'm creating a variable called centimeters, right? The scope of this variable is defined by the curly brackets. So the curly brackets define scope. So what that means is because I created this centimeters variable inside of this method, I can only see the centimeters variable inside of this method. I cannot see the centimeters variable down here in this method. That is not possible. Yes?
Is it the same thing, similar thing as the loop control variable?
Exactly, yes. I'm glad you made that connection. I was about to ask you, where else have we seen curly braces before? And one of the places we've seen curly braces is with loops. If you create a variable inside of a loop, a for loop, you can only use that variable inside of that loop, right? We've seen that before. If you need to use that variable outside of the loop, then you have to create that variable outside of the loop. It's the same concept. In that situation, we'd say that it has a loop variable, that variable has a scope of the loop, right? We see it more often with methods, so I usually more often would talk about this as having method level scope. I can see it anywhere inside of this method, but I can't see it inside of any of the other ones. And I want to prove this to you, right? You can actually verify this with the debugger. You know, I'm using the debugger a lot today, but it's such a useful tool. If I look at what variables exist to me right now, I'm in the main method, line 14. You can see what line's highlighted. I don't see inches. I don't see centimeters. Those variables do not exist. They only exist within this method. So only if I'm looking at a line of code within this method will I see those variables. But if I click step into, there's inches, that's the parameter, and centimeters is about to get created, so it will exist soon, right? So these variables are within the scope of this method. This one is actually a parameter. This one is just a variable that got created. Both of them can only be seen and accessed within inside of this method. As soon as the method is over and I return back to the main method, you'll notice they're gone. Inches and centimeters are no longer variables that I can see, that I can access anymore. I'm outside of their scope. So, you know, how might that come into play? Think about this for a second. Here we go. All right. I just made a small change. This used to say 10. Instead of saying 10, I made a variable called inches and set that to be 10, and then just plug the variable in here. Is this variable the same as this? No. They are not the same. They are not the same. They happen to have the same name, but they have different scopes. I have a variable in my main method called inches, and I have a parameter in my inches to centimeters method that is also called inches. I have two values with the same name. That's okay. That is allowed. That is not a problem, as long as they are in different scopes, right? So again, to run this through the debugger to show you what I mean, here's my value of inches. That's this variable right here. I'm in the main method, so it's referring to this variable. As soon as I step into this, you'll see that the value of inches is 10, and that's true, right? Because I passed it in there. But this is not, again, I want to repeat, this is not the same variable as this one. In fact, I can prove it to you. If I click over here on the method call stack, if I click on main, I'll see that I can actually look. So there's the variable of 10, here's the variable of 10, or perhaps an easier way of seeing this would be to finish the first time and look at the second one, right? Here I am on the second method call. Inches is still 10, but if I step into it this time, now inches is 15.7. Does that hurt your brain a little bit to think about? It's okay if it does. This is a confusing part. This is, I know from experience that this is a confusing part. Again, we have two values called inches here. One of them exists within the method, one of them exists within main. Or perhaps this will be another way of illustrating, you know, what if I just change the name of this a little bit? Now that they no longer share the same name, very clearly must be different variables. But let's think about what exactly is happening when these methods get called. So like on line 14, what is actually happening when I plug this variable in? It's doing, behind the scenes, it's doing an assignment. It's saying inches equals inches 2. Now go do the stuff that's in the method, right? That's how the values are getting passed to the method via the parameters. So when you call a method like this, it takes the value out of here, assigns it to the parameter, and then runs the code in the method with that parameter. It's a complicated concept though, so if you have any confusion, want me to repeat any of that, I'd be happy to. Yes? Yes. When you call a method and you put a value inside the parentheses, there's actually an assignment of sorts happening where this value is being assigned to this parameter. I don't actually say that. I don't say inches equals inches 2, right? But that is happening. That is part of the process of calling a method. It takes the value out of here and assigns it to this value. And the second time around, when I call this method, it takes the value of 15.7 and assigns it to inches, right? Yes?
In the line 14, what is that doing if it's not? I'm just not understanding.
What is the value of this variable? It's 10. So it's taking the 10 from this variable and assigning it to this parameter. I just introduced an extra step, right? This is a bit more direct. It's taking the value of 15.7 and assigning it to this. But there's no reason that I can't have this be a variable too. Or if you want to get really complicated, right? There's no reason I can't do some fancy math and stuff in here too if I really wanted to, right? If I have a reason to do something like this is okay too. As long as it is a double, right? As long as it is a double, it doesn't really care what the value is. It's just going to pass it to this parameter. So this method's getting run twice. The first time through inches is equal to 10 because of this value, and the second time through the method inches is equal to 15.7. And if I wanted to use it again for a different value, right, I could call the method again, plug in a third value, get a different result. Okay. Another thing that I want to point out is this is a similar idea, actually, as what I was just talking about, but slightly different. This idea that methods are being called by value. And so what that means is that when I take this variable y and I plug it into this method called square, when it actually squares that value here, it's not squaring this value directly, right? It's making a copy of the number 5 and then squaring that copy. In other words, if I set y to 5 and I say go square it and then I print out y again, I still expect y to be 5, right? I don't expect this method to change the value of 5. It's changing a copy of that value. I hope that makes sense. I'm again going to use the debugger to try and illustrate this point in more detail. So I am taking the value of 5 and passing it into this square method, which is going to multiply it by itself and then set it back to be x. So here I can see x is 5, right? After I do this arithmetic, x becomes 25. But the value of y here in this method remains unchanged. So I print out my value of 25 here, and this method is over. When I return to the main method, you'll see that the value of y is still 5. Again, you can think of this through the eyes of scope, right? This method has no idea that this value of y even exists. But this also really, I think, illustrates what's happening when you plug in a value to a method call. It's grabbing a copy of that and then using that copy through the method so that I don't manipulate, so that I don't change this original value of y. I think, again, if we happen to rename these the same variable, or rename these the same name, right? It looks perhaps a little bit more confusing, but again, remind yourself that I have 2 copies of x here. One that exists for this method, that is this parameter, and the second copy of x is only in main, right here. So when I change the copy of x in this method, because it is an entirely separate copy, the copy of x that exists in main remains unchanged. Does not get changed as a result. All right. We're going to talk about return values next. That is, I think, our last stop for the day, for the most part. So parameters are used to feed information into a method. Methods can also provide information back out. That's called a return value. So when a method has an answer, when it has a result, we call that a return value. There can only be one. So I'm allowed to have multiple parameters. You've seen that. I can have as many parameters as I want, just commas separate them. But for the output value, for the return value, I can just have one. So if you find yourself in a situation wanting to have multiple outputs, kind of in a pickle, we'll figure out how to solve that problem in a couple weeks. For now, though, the problems that we solve are going to be doable with just one return value. And so here's an example that computes the volume of a cylinder just using the formula from math class. You'll notice that instead of the word void here, I have the word double. But I could have used any type I want. I could have put int, string, boolean. You could even do, what would that be? An array? That's okay. Any type you can think of. In this case, double makes sense because, you know, I'm computing the volume of something. So having a double as the return value makes sense. Here, when I call the method, notice that I'm doing something else. In addition to just calling the method, I'm also assigning to a variable. So when I have a return value, when I have a return type declared, that means that when I call a method, it is going to give me a double that represents the result of that computation. If I wish to keep that, I need to declare a variable and store that value into a variable. This is a way that we can kind of get around the barriers of scope. So if I need information to get into a method, I use the parameters. If I need information to get out of a method, I use the return. Right? You'll see I actually have the word return here. Return serves multiple purposes for us, but in this case, we're using return to say, this is the answer. Right? Another way to think about the return statement, I mean, I might have coded it up more like this. Just breaking this up into 2 lines instead of 1, just to maybe make it a little bit more clear as to what's happening here, right? Do some computations whenever you know that you've finished, right? I have no more work to do. Return answers saying this is the result, this is the answer, this is the work produced by this method. So when I plug in the values of 4 and 10, it'll compute this, store the result in this variable, and then return that value. So that's actually going to be passed here, and then I can store that into this variable. And I'd like to show you that, again, using the debugger. Did I see a question over here?
Why, as for the return time, like, what is the difference if we said public static void or public static void?
Great, yeah, so void, I'm glad you asked about void, because void is worth talking about. Void means there is no return value. So you'll notice that in all of the examples that I've done prior to now, there's no return statement here. It doesn't say return anywhere. There is no output. There is no return value. There's no output. Also notice that I'm not trying to store any output, right? I just call the method and let the method do its thing.
So if the time is void, then we don't see a return in the method.
Well, I don't want to. Yes and no. Yeah, if the return type is void, I'm being very careful about what I say here. If the return type is void, there will be no output. There will be no actual value being returned. You can still use a return statement inside of this method, though, inside of a void method. And I'll talk about that a little bit later, but let me return to the example that we're working on and finish talking about return values. I'll come back to that in just a second, because you're asking some really great questions. Let me walk through this in the debugger and try to show you how return values work, because this is another thing that students get very confused on when they first encounter them. So here I am on line 14. Again, I'm in the main method, so that's where we always start. We start with the main method. Line 14. I'm about to compute the volume of a cylinder with a radius of 4 and a height of 10. And so I'll step into the method and see that it's going to compute the answer. Here it is, 502.6. That's my answer, right? When I reach this line, return answer, that does 2 things. It says, this is the output, but it also says, we're done. Return statements also mean, we are finished. There's no more work left to do here. You can leave now. You can go back to where you came from. So after this line executes, we're going to come back, and it's going to pass this value, 502 point something, out of the method. So you can see it says, volume cylinder returned this value. It's going to take that value and store it into this variable called volume right here. And at that point in time, I can print it out if I want to, right? I want to contrast that with, what if I forgot this part? Because this is something that I see a lot. Students will have a method, it computes something, it returns something, usually because that's what we've asked for, right? Write a method that computes and returns this thing. And then, somebody will say, I think my code's working, but I can't access the answer. I can't get it to tell me what the answer is. Well, consider what's happening in this situation. If I run through the debugger again, I'll step through. It's computing the answer. It's returning the answer. This is saying, okay, the result of this is 502 point something. And the way that I have this code written, I'm not saving it, I'm not storing it, I'm not writing it down. I'm saying, oh, thanks for that return value. Just throw it in the garbage. Just throw it right out. If you want to keep that value and do something with it later, you have to create a variable. You have to create a variable to store it. What kind of variable are you going to create? The same kind as the return type. It's always going to give me a double. Always. Always, always, always. So This is how we store the return value into a variable. Yes?
Sorry, another thing with like nesting
Mm-hmm.
methods.
Mm-hmm.
If you like exit a method that was already called from the main method,
Yep.
you return to the secondary method then. You don't go to the main.
You always return back to where the method was called.
Okay.
Yeah. It's going to take some getting used to. It's going to take a few tries walking through a program. But yes, you always return where the method was called, back from where we started from, every single time. Yep. That's why it's called return. We quite literally mean return from where you came from, return from where you were called, and continue on. Yes.
So when we return a value, that doesn't mean like it is like stored. We still have to store it. When we return, that value is just stored like in the computer, and if we don't store it, it just doesn't.
Correct. Yeah, correct. I also, I think you're kind of getting at a question. You didn't ask this question, but it's sort of the question that I wanted to answer anyway, because it's a common thing that I see students struggling with. Returning something and printing something are two different things. They are not the same thing, right? Printing something is the act of taking a value and showing it to you on the screen. Returning has nothing to do with showing you a value on the screen. Returning is simply taking a piece of information from one method and passing it out of that method so that we can access it from a different part of our code. So return statements are used to communicate information from one part of our code to another part of our code. That's what return statements are used for. They're for programmers, right? Print statements are to display information to the outside world. Yes, programmers want to see that info, but so do just the regular people, right, using our code. And they don't know what return statements are. They don't care what return statements are. That's not their job. They just want to use our program, right? So keep in mind what you're trying to do. If I'm simply trying to pass information out of a method from one place to another, that's a return statement. If I'm trying to display some information, print something on the screen, right, that's system.out.print. Students will often get those two confused. They'll print something when they mean to return something. Think about if I just print the answer here, this is a common mistake, right? Well, I mean, I don't want to say it's a mistake. Maybe there are some methods in which all we want to do is print. But the issue with doing it this way is that when I call this method, it's only printing. It's not returning. So it's not giving me any values back here. If I want to access the volume of the cylinder down here, I have no way of doing it because it's not returning anything. It's just printing. I can't take, a printed value and store it in a variable. It's not possible. Yeah.
What if you start a debugger in a non-main method?
Yeah, great question. Love that question. Let me fix my code back to the way that it was first real quick. The question was, what if you start the debugger somewhere besides main? You can do that. Absolutely. In fact, to illustrate the effect, let me just duplicate this line a few times, call this method a bunch. You can change the numbers if you want to, but I don't think it really matters for what I'm about to show you. Let's say I'm not worried about this code, right? Let's say there's some code happening here, but I feel like this code's working okay. I'm not worried about this code. I think maybe the problem is here. There's an error in my code, and I think maybe it's here. It's not here. I can set the breakpoint here. Think about, though, I'm calling this method 1, 2, 3, 4, 5 times. So I'm going to hit this breakpoint 5 times, once for each method call. So when I start this in debug mode, oh, I had my old breakpoint set down here. Whoops. Let me turn that off and try again. So when I start this in debug mode, it does stop here. It doesn't stop in main, but which one am I in? I'm in the very first one with 4 and 10. And if I step through, right, we'll see that, okay, yeah, I was on the very first one. And then if I go through, this is the continue button or the resume button. right? Which allows you to just keep going until you hit the next breakpoint. Now I'm in the second method call. So this is the second time in the method. I can see I return here. If I resume again, you'll see this time I'm very clearly in the third one. There's my 5, right? So it'll hit the breakpoint once for each method call. That is a useful trick though. Again, if I don't think the problem is here, then I don't necessarily want to set the breakpoint here. If I think the problem is here, then I can set the breakpoint here, and that lets me skip all of this stuff and go directly to where I think the issue at hand is. Good question. Learning how to drive the debugger is a skill in itself, but a very useful one, in my opinion, to learn. Let me see where we're at here on my notes. Okay. We've got 20 minutes left. Perfect. Perfect. So this is actually kind of already did this example with the last example. This was just trying to show you that printing is usually not what we want. I think we would actually want to switch this to use a proper return type instead. But for the sake of time, I'm going to skip ahead to this one. All right, since this one is relevant to us. I wish to write a method called random number in range, and this is a practice problem from the text, from the prep work, and it even gives you, I think, the signature. But just as a little review, all method signatures, at least for now, we're going to start out with these two magic words: public static. The next thing that comes is the return type. So I'm generating a random number. I think we're generating random integers. I actually don't remember what the exact problem asks. If we wanted doubles, we could, of course, have this be a double. Either way. After the return type, we specify the name of the method. And then after the name of the method, we always have parentheses. Even if there are no parameters, we always have parentheses. In this case, we do have parameters. I want to generate a random number between this value and this value. We've talked about how to do this before, so I'm going to go through this next part slightly quickly, since I've covered this equation in class prior to the first exam. We're going to multiply by the range, which is max minus the min, and then add the min. So the math, that's not anything new, really. The new things here are the fact that we've wrapped this into a method that is going to return these values. And if I want to test it, I have to call it. So if I run this code right now, what's going to happen? Anybody know? Nothing. Absolutely nothing. There's a couple ways you could have come to that determination. One, I always start in the main method. Look what's in the main method. Absolutely nothing. Right? Two, the other way to think about it. I wrote this method. This is just a template. This is just a template. The method definition is just a definition. It just says what the method is and what it does. We have placeholders. Those parameters are just placeholders. I can't actually run through this until I specify what those values are. So I have to give you specific values for min and max in order to be able to use this. We have to call the method. I have to call this method. So in order to call this method, we type the name of the method that we wish to call. And then if it has parameters, which it does, we have to supply values for those. So I want to generate values between 10 and 20. All right, now if I run this code, what am I going to see? Still nothing. A couple other ways you can think about why we're not seeing anything. Is there any prints? Definitely not. I didn't tell it to print anything anywhere, right? Printing is how I get stuff on the screen. If I don't print anything, no stuff on the screen when I run the code. It's as simple as that. So what am I printing exactly? What do I want to print? I probably want to print whatever random number gets generated. So that random number is getting generated and returned. If I want to keep that value, I need to store it in a variable. And then if I wanted to, I could print that out. Okay. Now we should hopefully see some numbers. 11. And if I really wanted to test it, I should probably run it, a bunch of times. Stick this in a loop. Fix my indentation, fix my loop variable that I didn't declare properly. All right, now we can really test this and see. It's giving me numbers between 10 and 20. Not including 20 though, huh? I'm not sure if that's what the problem asked for or not. If the problem wants 20 to be included, then we need to include a 1 in here somewhere, right? I'm not too worried about that. I'm more worried about the flow and the method execution today than the actual math. All right, let's wrap it up with a final example today. This one is not from the text. This is one that I came up with before class today, so you will not find this one in the textbook, but I think it's a good way to kind of tie everything together. Notice that I've thrown a few methods at you this time. So I've got one called A that just returns A. I've got one called B, and if we look at what B is doing, it calls A, right? And then I've got another one called C that calls B and A. It calls both of them. So I want to show you, this is, I think, a more realistic example. Everything that I've shown you so far today is go to the method, come back. Go to the method, come back. And that's true, that's how methods work, but in real life, I'm going to have lots of methods operating at any given point in time. It's not just going to be do one method, come back, do one method, come back. So here, I'm going to set a breakpoint at line 23 and step through this and just see if we can make sense. Or actually, let me run it first and show you what it does. ABCA. It's meant to be kind of a trace, right, of our path through the methods. So let's see if we can use the debugger to help us out, understand what's really going on here. I'm going to start at the main method, line 23. That's the first line that gets executed. And it's calling method C. It says go do whatever C tells you to do. So if I step into that, we'll notice that C gets added onto the stack over here, right? I started in main, and now I'm in method C. What does method C tell us to do? Method C says, go do method B. So I'm already jumping somewhere else. That's okay, we can do that. If I click step into here, notice what happens. I'm now in method B. Started in main, I went to C, now I'm in method B. Method B is saying go to method A. Go do whatever method A is telling you to do. Okay, you can do that as well. I step into method A, started in main, went to method C, went to method B, went to method A, right? It's keeping track of every method that I go to. And I'm going to work my way back down as well. This is exactly the path that I'll work my way back down through eventually as well, right? But let's continue tracing. Method A is the simplest one. It just says return A. All right, that's an easy one. I'm going to take that value of A and I'm going to store it in this variable called result. Notice that after I returned from A, method A is no longer on the stack, right? It's finished, so it's been removed. So now I'm in method B again. All right, A returned the value of A. Here it is, stored in my variable. I'm going to tack another letter on, B. So once the B method is done, this is what I have, AB. But we have to now return to C, right? That's where we originally started. So I go back to C. There's the AB. It got returned from method B. I'm going to tack a C onto it. And then look, I'm saying, oh, go back to method A again. Why not? There's no reason why I can't do this. If I step into method, whoops, what did I do wrong there? Did I click the wrong button? Uh-oh. Okay, I don't know what happened there, but I finally made it to where I wanted to go. Method A, so now it says started in main, went to method C, went to method A. Did I also go to method B? Yeah, but that's already been taken care of. That's already done, so I don't see that here. Method A does its thing, which is to return the value of A. That value is going to get tacked onto my result. I'll return that result back to main. That's the only method that's left on the call stack. And so we can see ABCA is the final result. But every method call added another letter to that, right? Every method call added another letter to its trace and passed that result around. Notice that I haven't printed anything. I've been using return values this entire time, have not printed a single thing until the very, very, very end when I print out the whole shot. One final thing that I want to bring to your attention, I think I should have mentioned this when I was talking about return statements, but I do want to make sure that I cover this. If you have an if statement, right? I don't know, it doesn't matter. If something, this is just a made-up condition, right? Whatever. I can have a return statement inside of here. That's perfectly allowed. But there's a problem. You can see Eclipse is unhappy. It says this method must return a result of type string. Aren't I doing that? There's a return statement right here. What's the problem? What if this is false? Then what am I returning? So if I give you a statement like this, whoops, that's still true. If I give you a statement like this, what am I returning? There isn't anything specified. If you're going to use an if statement inside of a method, right, you always have to return something. Always. So if I return something inside of an if statement, I also probably have to include an else statement to specify what to return down here. So I can have multiple return statements within one method. That is absolutely a thing that can happen, right? Right? Have to make sure that no matter what path you take through the method, if you've declared that I'm giving you a string, I always have to give you a string. I can't give you a string sometimes and not give you a string some other times. One final thing that I want to reiterate, I've already said this, but I want to show you an example. Return method means two things. It means this is my answer, but it also means the method is over and there's no more work left to do. So what do I mean by that? If I come down here and I try to say, int x equals 7, int y equals x times 2, right? X plus plus. Eclipse is also going to get mad at me. It says unreachable code. Unreachable code. Why is it saying this code is unreachable? The return statement says the method is over. There's nothing left to do here. Go back. So putting lines of code after a return statement is useless. These will never get executed. When it hits this return statement, it says this is my answer. I don't need to stay here anymore. This method is over. All right? So that can be another trap that people fall into. This is a trap that people fall into with loops. Using return statements inside of a loop can be tricky. be careful. If you have a return statement inside of a loop, it's possible that you may not actually be looping, right? That return statement could potentially stop the loop early. You may not actually be looping as many times as you expect. That's not to say you can't do those things. You just have to be aware of how they interact, how the return statement affects the execution of for loops and if statements, etc. All right, I have given you a lot to think about. I think I'm going to go ahead and wrap it up here for today. If you have any questions, I'd be happy to chat. I'm happy to chat about exam regrades or anything else. Otherwise, I hope you all have a good week, and I'll see you in studio on Wednesday and Thursday.